In question number 26, two inclined planes are given at 30 and 60 degree, and we have to find the acceleration of block A with respect to block B, right? So सबसे पहले दोनों का acceleration xy vector form में निकाल लो. So in this direction, the acceleration of A is given by g sine 60 degree, that is root under 3g by 2. इसे फर्दर हम x और y एक्सिस पे रिजॉल्व करेंगे क्योंकि रिलेटिव के लिए मुझे वेक्टर फॉर्म में चाहिए होगा. एंड this angle is 60 degree over here. Okay, this angle is 60 degree. So horizontal one will come with cos 60. Cos 60 means 1 by 2. So this is root under 3g upon 4. Vertical one will have sin 60. So this will be 3g upon 4. दो बार root 3 आ जाएगा. That will give you 3. Likewise, for block B, this is g by 2. G sin 30, g by 2. Now horizontal and vertical axis. This angle is 30 degree. So cos 30 is root 3 by 2. So this will come root 3g by 4. And here it will come g by 4. Acceleration of A with respect to B is your acceleration of A minus acceleration of B. X-axis will cancel out because both are same. So I am not writing that. About y-axis, it is minus 3g by 4 j cap minus of minus g by 4 a के लिए लिख रहा हूँ यहाँ पे like this. ठीक है, b के लिए लिखा अभी. Now on solving this we are getting minus g by 2j. So there is acceleration on y-axis only, and that is 4.9. Okay, g by 2 means 4.9. Answer is D. So in question number 29, curve is given, the surface is given by this equation. So y equals to x cube will appear something like this. Y equals to x cube upon 6. Okay. Coefficient of friction is given 0.5. The maximum height on the above the ground at which the block will not slip. Okay. See, for not to slip, we know that tan theta will become equals to mu when the block is about to slip. Okay. Now अगर y का इक्वेशन दे रखा है तो यहाँ से डिफ्रेंशिएट करने पे हमें dy by dx मिलता है, which is a tan theta. So dy by dx is coming 3x square upon 6, that is x square by 2. Okay. So from here we will get x square upon 2 equals to 0.5. So x equals to 1 आएगा. Okay. Now when I put x equals to 1 in the equation, I'll get the y. Y means height. So y is coming as 1 upon 6. D is the answer to this question. So in question number 30, in the given figure, two blocks are given. A has 20 Newton weight and B has 100 Newton weight. They are being pressed with the help of a force F. Right. The coefficient of friction between the block is 0.5 and that of the wall is given as 0.15. So friction force applied by the wall on the block B is, right? See, because this has been pressed, so the system is not moving. Okay. So just observe A. What will happen to A? There is a force of 20 Newton downside on A, and because it is not moving, there will be a friction on it by B, right? And how much it will be? It will be 20 Newton. Okay. Now coming to block B, because of its weight, there is 100 Newton downside. Now friction, action reaction between A and B. So on B, the friction will be acting downside, and that is 20 Newton. And because it is not moving, there is an upside force by the wall, F dash, and it has to be balanced, and therefore 20 plus 100, the upside force by the wall on block B will be 120. Okay, 120 Newton, 100 plus 20. So the answer is A. In question number 31, there is a track given PQR, and this complete track is rough. Okay, this complete track till R from P is rough, and a block is released from rest at P which stops at R. Mu the coefficient of friction for the rough surface. Okay, and it is also given that the energy lost by ball in part PQ, that is incline 1, is equals to that lost in QR. Okay, and no energy is lost by the particle in changing the direction at PQ to QR. The coefficient of friction mu and x, that is QR, is how much? Okay, so this is the question. Now, as it is said that in path PQ the energy lost, so the energy is lost because of the friction, and this question is from work energy, so we'll be using work energy concept. So work done by friction on the part PQ is given by minus mu mg into horizontal length. How much is horizontal length? That is, I'm talking about OQ. This length I am talking about, OQ. This will come tan theta equals to this, so 2 upon tan theta, that is cot 30. This OQ will come 2 root 3 using tan theta, tan 30. Okay, now this is 2 root 3. I am using the work done by the friction in part PQ, which is equals to mu mg friction force in part QR, that is x QR. Now mu mg will cancel out, and x is coming as 2 root 3. If we solve it further using 1.732, we get 3.45, which is approximately 3.5. Okay, 3.5. Now further, how much was the total energy? It was mgh, which is completely lost due to friction. Now using work energy theorem, potential energy loss equals to work done by friction in path P to Q to R. How much is the loss? So you will write mg into 2 mgh, and the total loss will be given by mu mg and the horizontal distance, that is OQ plus QR. Since they are both equal, so mu mg into, we can say 2 times 2 root 3. Okay, and on this side mg. So mg and mg will get cancelled. 2 and 2 will also get cancelled. We are getting mu equals to 1 upon 2 root 3. Now when you solve it, it will come approximately 0.29, right? So the answer to this will be B. Now in this question, M2 is given 10 kg, M1 given 5 kg, right? And this surface is smooth. The surface between M and M2 is given smooth, and this surface is given, the table surface is given 0.15, right? Minimum weight M that should be put on M2 to stop the motion. See how the motion will stop. On this side M1G is acting, so on this side there should be friction force, right? Limiting friction force. So that limiting friction force and M1G should be balanced, right, in order to not move the system. So F max equals to M1G. Now F max कैसे आएगा? तो mu into m2 plus m से आएगा, ठीक है. So it is like this. Now substituting and simplifying. So 0.15 m2 means 10 plus small m, g will get cancelled, equals to 5. ठीक है. Rest is solving. So on simplifying this, we get 350 by 15, which further gets simplified by 5. So 70 by 3, that will come 23.33 kilogram. So this is the mass m required to keep the system at rest. See the answer. So in this question, there are two blocks given. Block A is above the block B. This is B and this is A. Right. 4 kg given and 5 kg given. There is no friction between B and the table, and there is some friction between A and B. The question also says, means there is a correction in this line. This question is not like this. The question given is minimum force to slide A on B is 12 Newton. Okay, this is the question, and here written minimum force that can be applied on A so that both the blocks move together is 12 Newton. This is not the. So kindly correct this question. The minimum force required to slide block A over B is given by 12 Newton. Now, when you apply some force on A in order to slide, A will only slide when it will overcome the friction force acting on A, right? It means the maximum friction on block A by B is given by 12 Newton, right? Now in next part of the question says, what maximum force can be applied on B for them to move together? Okay. So now we have to find a force on B, let us call it F dash, so that they can move together, and this force should be maximum. We know that when force applied is maximum, so friction force is also acting maximum, and direction of friction would be on B left side and on A right side, right? So first decide what is the common acceleration, and this is the maximum acceleration. So common acceleration is given by F dash upon total mass, that is 9. Now with this acceleration, the two blocks are moving. We will work on A. So on A, there is friction force on the right side, and I know how much is this force, which causes this block to move with acceleration AC. So our force equation will be F equals to mass into acceleration for 4 kg block, right? 12, 4 and F dash upon 9. On solving this, we are getting 27 Newton. So this is the maximum force for the two blocks to move together if acting on B. Answer is question number 34. This is from this question is from collision, so we have to use conservation of linear momentum in order to solve this. So this is a block of 0.8 kilogram, and this is a bullet of 4 gram moving with 300 meter. Now this bullet hit the block. Block will gain some velocity, let's say v, and because this block is on rough table of coefficient of friction 0.3, so it will stop at some point of time. So question given is, how much is that displacement in the block? Okay, so our objective is to first find this v using conservation of linear momentum, and then we'll be using v square equals to u square plus 2as. Okay, now according to conservation of linear momentum, initial momentum before collision equals to final momentum after collision. इनिशियल मोमेंटम में केवल बुलेट का मोमेंटम होगा, सो 4 × 10⁻³ किलोग्राम into speed of the bullet, that is 300, equals to 804, because the bullet and the block, we have to take the combined mass now, into 10 to the power minus 3. This is the total mass of the bullet block system after collision, and moving with, say, velocity v. So this v is coming as 1200 upon 804. We can take it approximately as 3 by 2, means 1.5 meter per second. So this is the speed with which it is moving. How much is the retardation? See, retardation on rough surface is given as mu g. So it is 3 meter per second square is the retardation. So x equals to v square upon 2a. Now this is 1.5 into 1.5. Rest is the solving. 2 into 3. So it is coming 1.5 by 4. So it is 0.379. So the answer is A. So in this question, a heavy box is being dragged, right? Person A pushes, underline this, pushes at 30 degree, and minimum force required to do so is Fa, while person B pull the box at 60 degree and minimum force required is Fb. So what is the ratio if mu is given? Root 3 by 5. So we need to remember this formula, as I have told you in the classroom also. In case of push, we have minimum force to move the block is mu mg upon, नीचे में माइनस आता है यहाँ पे, so it is cos 30 minus mu sin 30. This is your Fa basically, not minimum, this means minimum force, but Fa, and B is pulling, so denominator में plus आएगा, so Fb will be mu mg upon cos 60 plus mu sin 60. Right. Now we have to take the ratio. So it will be Fa upon Fb, which is given as cos वाला part ऊपर चला जाएगा. So cos 30 is 1 upon 2. So keep solving this. In the numerator, when we take this, तो 3 plus this 8 upon 10 आ जाएगा numerator में, and denominator will be 5 minus 1, that is 4 root 3 upon 10. So after solving this, we are getting 2 upon root 3 like this. So this is the answer. In this question, a rocket is fired vertically upward with acceleration of 2g, right? An inclined plane inside the rocket making an angle theta with the horizontal. A block mass m is kept. Minimum coefficient of friction between mass and the surface so that mass does not move. Okay, so this is your rocket. Which is going up with acceleration 2g. This angle is theta, and here is the block which is at rest. So obviously this downside force must be equated with upside force which comes due to friction. Now if we talk about this accelerated frame, there is an effective g, and g effective in this case is g plus a, that gives you 3g, because a is 2g given. So g effective is 3g. Now on downside plane it is mg, so m into 3g into sine theta, this is the force acting down the plane. Likewise, friction maximum which will require to balance it is mu m into 3g cos theta up the plane. Because it is not moving, so these two forces must be balanced, and on solving this we get mu equals to tan theta. देखो, m into 3g into sine theta, mu m into 3g into cos theta. From here we get tan theta equals to mu. So coefficient of friction must be equal to tan theta in order to keep it at rest. In this case, there is a particle on which F force is acting, which varies with time t, like this. So the best way to represent the straight line graph means इनमें से कौन सा पैरामीटर होगा जो straight line graph देगा? If we see the options, it is the velocity versus time. Okay, so our focus is to get velocity from force. We know that force से acceleration आएगा, acceleration को integrate करेंगे तो velocity आएगा. So F equals to ma equals to r upon t square, a equals to r upon m into t square, dv equals to r upon m into dt upon t square. So when we integrate both sides, v equals to r upon m, and what we see, t to the power 1 upon t square is minus 1 upon t, right? Okay, there was a velocity in it, F equals to r upon t square into v, right? So there will be v at this point, and so v will come over here. Now when you integrate it, it is ln v equals to r upon m into t with minus sign, with some constant. Okay, now if you see this as y, this as 1 upon t as x, so some constant p into x plus c. So basically this x is 1 upon t and y is your log v, ln v. So the graph between ln v and 1 upon t will give you a straight line. So answer to this will be D. In this question, a trolley is given of which this point is fixed. Okay, right point is fixed and left point is movable because of the roller. Now you know that when this move on the right side, 2 kg block will go up. So the question is, when the point moves with constant velocity, right? This point is moving with constant velocity, then what will happen to the 2 kilogram, means what is the velocity or the speed of the 2 kilogram. Now see, this is a constraint case. So 2 kilogram is at some height. We will take a height y over here. This length is x by 2, and as x is decreasing, so x by 2 is also decreasing. This is the length of the rod L. So we need to connect this y, x and L, where L is constant, x is decreasing and y is increasing. So Pythagoras theorem say L square equals to y square plus x square upon 4. We need to differentiate it because x is changing, so we need to differentiate it. Accordingly, y will come, dy by dt will come. So L square differentiation is 0, 2y into dy by dt, 2x into dx upon dt upon 4. After doing a little rearrangement, dy by dt equals to minus x upon 4y into dx upon dt. Now according to question, this is given constant dx upon dt, and we will talk about the magnitude because this minus sign is indicating when x is decreasing, y will increase. Now focus on this factor. X is decreasing, so what is happening to dy by dx? That is also decreasing. When x is decreasing, dy by dt is also decreasing. and dy by dt is the speed of the block 2 kg on y-axis. Similarly, because in this process y is increasing and y is in denominator, dy by dt is still decreasing. So we can assert that the speed of the block is decreasing. Okay, so B is the answer to this question.